Hi everyone. Today I'm going to present my final Raman spectrometer build. On this slide, I have shown my updated Raman spectrometer instrument. As you can see, it is a very budget-friendly at-home build. The green laser pointer is secured to styrofoam and to the spectrometer box so that the alignment remains constant. The laser goes through the sample and then through the long-pass filter lens to enter the spectrometer. The objective of the long-pass lens is to try to filter out some of the Rayleigh scattering so that the Raman scattering shows up more in the results. Inside the spectrometer, the instrument hasn't changed since my feasibility presentation. The light reflects off the mirror and onto a DVD used as a holographic grating. And finally, the digital camera captures a picture of the Raman scattering. Not pictured in these two figures is the black garbage bag that I used to cover the instrument and the sample. This takes away the outside light from the system so that the holographic grating displays only light from the source. In order to test the instrument, I chose to use a sample of diluted acetic acid, aka white vinegar, because it's a clear liquid and acetic acid has published Raman spectrum that I can compare my experimental results to. Figure 3 displays the results that I obtained from my acetic acid test. As you can see, the picture captures the holographic diffraction on the CD. Unfortunately, there was also some light that got into the spectrometer. I believe this was from the camera flash that I tried to block, but clearly some got in. However, this photograph is still usable as a result since the majority of the light on the diffractor is from the laser. Using image J, I defined a region of interest from this picture, which is shown in figure 4. This picture size is 2800 by 400 pixels, so that the intensity plot to show the Raman spectrum will be relatively lined up with the published Raman spectrum graphs. In order to view the Raman scattering and see the results, I used MATLAB to analyze the region of interest picture and plot the intensity of red, green, and blue light against wavelength. The plot of all the RGB light is shown in figure 5. We can take out the green light from this plot since it's mostly Rayleigh scattering from the green laser and not what we're looking for. Figure 6 shows just the red and blue intensity plots. The blue light comes mostly in that section that had a lot of green light, so this light can be dismissed as excess light in the system, and will be mentioned later in the sources of error. We are left with figure 7, which shows the intensity graph of only the red light. On this slide, the comparison between the known acetic acid Raman spectrum, which is shown in figure 8, and the experimentally determined Raman spectrum for acetic acid, which is shown in figure 9. If omitting the excess light from the area where there was a lot of that green light, the areas that I have framed in blue in both figure 8 and 9 are similar enough to compare. The peak of the known spectra goes up to 90, but the peak of the experimentally determined spectra goes up to 135. The margin of error between these two areas is roughly 50%. Finally, here are some sources of error I've noted in my experiment. I believe the majority of error in my experiment comes from the extra light getting into the system. Mostly this is from not enough of the Rayleigh scattering being filtered out of the spectrometer, and also from the camera flash. I was on a budget while making this instrument, so the plastic in the middle of the DVD and the mirror negatively affected the results. Also, some of the black tape I used got in the way of some of the reflection, and the laser and beaker were not completely stationary, which meant that I couldn't test the accuracy of the instrument. That's all from me. Here are my references. Thank you, everyone.